Chernobyl's legacy. Radiation effects now seen in children of exposed workers decades after the Chernobyl disaster. Scientists have confirmed for the first time that genetic damage from radiation exposure can be passed down to subsequent generations. This groundbreaking finding, based on a study of children born to cleanup workers and military radar operators, establishes a clear link between parental irradiation and measurable changes in offspring DNA. The transgenerational effect. How it works for years, it was uncertain whether the effects of ionizing radiation, IR, could persist across generations. This research team from the University of Bonn examined children of those exposed to radiation, focusing on clustered de novo mutations, CDNMs. These aren't entirely new mutations, but rather patterns indicating breaks in parental DNA caused by radiation and then imperfectly repaired in offspring. The study compared 130 children of Chernobyl workers, 110 children of German radar personnel, and 1,275 unexposed controls. Results showed a significant increase in CDNMs in the children of exposed parents, 2.65 per child in the Chernobyl group, 1.48 in the radar group, and only 0.88 in controls. Even after statistical adjustments, the difference remained significant. The higher the parental radiation dose, the more clusters appeared in the child's DNA. This aligns with how radiation creates reactive oxygen species, breaking DNA strands. While such breaks are often repaired, imperfect fixes can leave behind clustered mutations. This is why researchers looked for these clusters, rather than entirely new mutations. Why this matters: long-term consequences and future monitoring. Although the study found no increased disease risk in children with these mutations, the implications are far-reaching. Most mutations occurred in non-coding DNA, reducing immediate health concerns. However, the fact that radiation exposure leaves detectable traces in offspring DNA proves a transgenerational effect. The long-term consequences of such subtle genetic changes remain unknown. The researchers point out that older fathers already pass on more mutations than younger ones, and the risks from radiation exposure seem lower than those associated with paternal age. But this discovery highlights the need for strict safety protocols and ongoing monitoring for those exposed to radiation. Study limitations and future research. The study acknowledges limitations. Historical radiation dose estimates are imperfect, and voluntary participation may introduce bias. However, it provides the strongest evidence yet that radiation exposure can affect future generations. The potential of transmission of radiation-induced genetic alterations to the next generation is of particular concern for parents who may have been exposed to higher doses of IR and potentially for longer periods of time than considered safe. This research underscores that radiation isn't just a short-term threat. Its effects can linger in the human genome for decades, emphasizing the importance of vigilance and caution in high-risk environments.